After replaying this level in Super Mario 3D World, I wanted to make an enemy similar to the Walleye in my 2D platformer. But there is a problem with this. In 3D, it's very easy to see how this enemy would block the player's movement. In 2D, just moving side to side doesn't really do much to block anything. To fix that, I wanted this enemy to have a movement system focused on blocking the player's projected movement. Of course, making this enemy AI was not done on my first try, but 2 coordinate points helped me fix the main problems with it. But before we get to that solution, for the enemy to block a player's projected movement, I wanted the enemy to behave in 2 ways. When the player does simple straight jumps, the enemy would move right under the player so that they end up landing on the spikes. Next, if the player were to do a parabolic jump, moving left or right midair, the enemy would wait 1.5 seconds before charging at the player. And because of the emphasis on this enemy being able to block player movement, I decided to name it the Blocker. While I was planning the behavior of the enemy, I also focused on its visual design. Usually, most of my designs are focused around simple geometry, colors, and symmetry. But something about the slight inexactitude of the brick and the Walleye's texture added a bit of charm. So I also decided to experiment by randomizing both the colors of the brick wall and the size, shape, and rotation of the spikes. But now I had another problem to focus on: how the blocker would move. For my earlier plan to work, it relied on one key element of the enemy AI. No matter where the blocker is, it should react within half a second of the player's movements. Even for the parabolic jump, when the player has to wait, the actual reaction of the blocker should still be half a second. And that means the same way I made my other enemies move would not really work for this. Which led me to something that was both a solution and a problem that broke the entire enemy AI system: tweens. To best explain what a tween is, let's look at 12-year-olds for an example. They're in between being a child and a teenager. In the context of animation, we can think of a child as a start frame and a teenager as an end frame, and 12-year-olds, or tweens, are the frames in between. We can apply this concept directly to the movement and the position of the blocker, because tweening can help with all of the movement in between the start position and the end position. The great thing about tweens is that the end frame is already decided. Whether that's under the player or towards them, all I have to do is decide when it happens. In that case, how do we decide what point the end position is? The answer might seem simple at first: the player center X position. And this does work very well for the straight jump reaction, but for parabolic jumps we have to do a bit more work. And by a bit more work, I mean something that would end up becoming the first coordinate point that helped me make my enemy AI behave properly. If you remember, for parabolic jumps, the enemy waits 1.5 seconds before tweening, but this does not account for the fact that the player can still move horizontally within that waiting period. So by the time the blocker tweens to the player's center X position, the player's actual position would be different. To account for that, we can choose a different reference point that's a bit past the player. In this case, we can target a point that is 250 pixels from the player center X position, and that would allow it to tween to the correct spot. Now, this point could be to the left or to the right of the player, so in order to pick which one, we have to account for the direction of the player from the blocker. I did this by creating a variable for the blocker called playerdir. Whenever the player's X position is less than the blocker's X position, playerdir is -1. If the player's X position is greater than or equal to the blocker's X position, playerdir is +1. That way, whenever there's a tween to go to the playerdir can be multiplied by the distance the blocker needs to travel to the player in order to move in the right direction. However, as I mentioned before, tweens also cause some issues with the blocker's movement. You see, the bad thing about tweens is that the end frame is already decided, which means that even if the end position was inside a wall, for example, it would still clip through. So, to fix this, my first thought was, would it be possible to stop the tween before it reaches that point? And that led me to the second coordinate point of my solution. I started off by making another point that had an X position that was 1600 pixels from the blocker. And because we have the variable player_dir from earlier, we can change where this point appears to be where the blocker is currently traveling. After that, I could create a simple conditional, that if this point ended up inside the wall, then the tween for the movement would be stopped. That way, the tween could be stopped before it reached the end position, and clipped into the wall. With that, the enemy AI for the blocker had been fixed, with 2 basic coordinate points. In the end, I think this shows that even simple solutions are valid when it comes to creating ideas that might be more complex than you first realized. It's very easy to overcomplicate a creative process for yourself, but taking the time to understand and break down what it is you are trying to do can prevent something from blocking progress. And maybe, while we're on the subject of blocking, I should remind you that there's nothing blocking you from hitting the subscribe button. Thanks for watching.